Welcome to Chloe Tech AI. AI is not only transforming the world, but also introducing a plethora of new terms that many people have yet to catch up with. To decode these monumental changes, we need to start with concepts, a lens that helps you see the world more clearly. In this video, I will explain the 20 most essential AI concepts in the simplest way possible, accompanied by real-world examples. Let's explore together. Group 1, Core Concepts. 1. Artificial intelligence, or AI. AI enables computers to think and act intelligently like humans. It is a field of computer science that develops systems or machines capable of learning, reasoning, and performing tasks requiring intelligence. For example, virtual assistants like Google Assistant or Apple Siri answering weather-related queries. Applications include Amazon Alexa for smart homes and IBM Watson for business data analysis. 2. Machine learning, or ML. ML allows computers to discover patterns from data independently, much like a student practicing without direct teacher assistance. For instance, Facebook, now Meta, automatically tagging friends in photos, or Google Photos, grouping images by faces. Applications are Netflix recommending movies, Spotify suggesting playlists, and Amazon providing product recommendations. 3. Deep learning, or DL. DL utilizes multi-layered neural networks, enabling machines to automatically understand intricate data without requiring explicit instructions. It is a subset of machine learning that employs artificial neural networks modeled after the structure of the human brain with multiple layers. Deep neural networks. These layers allow the machine to automatically extract data features, improving accuracy in processing images, audio, and language. Deep learning powers technologies such as speech recognition, facial recognition, and machine translation. An example is YouTube recommending videos tailored to your preferences. Applications include Tesla's self-driving cars, TikTok's content recommendations, and Baidu Translate for language processing. 4. Artificial Neural Network, or ANN. ANN mimics the human brain, allowing machines to learn from examples. It is the foundation for deep learning. For example, ANN differentiating between cats and dogs after analyzing thousands of images from ImageNet. Applications are Google Cloud Vision for image classification and DeepMind using ANN for medical research. 5. Natural language processing, or NLP. NLP helps machines understand, analyze, and generate human language. Applications include Microsoft Azure Cognitive Services and Amazon Comprehend, analyzing customer reviews. Now that we've covered the basics, let's move on to real-world AI applications you encounter every day. Group 2, Applied Technologies. 6. Computer vision, or CV. CV enables machines to see and interpret visual content like images and videos. For instance, Tesla's self-driving cars recognizing lanes and traffic signs. Applications are Google Lens identifying objects through cameras and Apple Face ID for secure device unlocking. 7. Speech recognition. Machines convert spoken language into text, eliminating the need for manual typing. An example is Google's speech-to-text transcribing "I want pizza" accurately. Applications include Amazon Transcribe for meeting recordings and Zoom adding subtitles automatically. 8. Reinforcement learning, or RL. RL trains machines through rewards and penalties, much like training a pet. For example, DeepMind AlphaGo beating world champion Lee Sedol in Go. Applications are Waymo optimizing driving behavior and OpenAI training robots for object manipulation. 9. Transfer learning. Transfer learning reuses knowledge from one task or domain to solve a new one, saving time and resources. For instance, a model trained to recognize cats is fine-tuned to identify lions and tigers with minimal data. Applications include fine-tuning GPT-4 for specialized healthcare or financial chatbots. 10. Generative Adversarial Networks, or GAN. GAN consists of two artificial neural networks competing against each other, operating as follows. Generator, data creation network. This network generates new fake data, such as images or audio, aiming to make it as similar to real data as possible. Discriminator, data differentiation network. This network analyzes the data to determine whether it is real or fake. These two networks compete through multiple training iterations. The generator strives to produce increasingly realistic fake data, while the discriminator becomes progressively better at distinguishing real from fake data. The end result is that the generator produces fake data that is nearly indistinguishable from real data, including realistic images, audio, or videos. An example is NVIDIA's GANs generating hyper-realistic human faces. Applications include creating prototypes, enhancing old photos, and generating music for games. Group 3, data and optimization. 11. Big data, massive, diverse, continuously updated datasets that AI requires for analysis. For instance, think about Amazon analyzing millions of shopping behaviors daily. Applications include Alibaba optimizing logistics and Netflix studying viewer habits. 12. Data mining, extracting trends and patterns from large datasets is like finding gold nuggets in sand. For example, JP Morgan detects fraudulent transactions from millions of records. Applications include Walmart analyzing sales data and LinkedIn identifying professional connections. 13. Hyperparameters. Configuration settings like neural network layers or learning rates are adjusted before training. Proper tuning ensures models learn effectively. For example, selecting optimal learning rates on Amazon SageMaker. Applications include building efficient spam filters on Google Cloud ML. 14. Data augmentation, expanding training datasets by transforming existing data, like flipping or rotating images. For instance, rotating cat images on Google Colab for more robust recognition models. Applications include improving image recognition on Apple products and enhancing X-ray diagnostics in healthcare. 15. Anomaly detection, identifying oddities in data like suspicious transactions. For example, PayPal detects unusual transactions to prevent fraud. Applications include Cisco network monitoring and factories detecting early equipment failures. Finally, let's dive into the most exciting group yet, trends and the future of AI. Group 4, trends in the future. 16. Artificial General Intelligence, or AGI. AGI aims to create a versatile AI capable of performing a wide range of tasks, much like humans. It represents the ultimate goal of AI, developing an intelligent system that can carry out diverse tasks, learn, and adapt to new environments without requiring specific programming or specialized data. AGI is still a research direction and has not yet been achieved in practice. Imagine a future where an AI can provide financial advice, sing lullabies, and play chess simultaneously. Future applications include interdisciplinary research and all-in-one office assistance. 17. Explainable AI, or XAI, ensures AI models explain their decisions, increasing transparency and trust. For example, AI systems in banks justifying loan approval decisions based on income and credit history. Applications include transparent AI in healthcare for diagnosis, finance for risk analysis, and law for automation decisions. 18. Application programming interfaces, or APIs, act as bridges between software, enabling data and feature sharing. For instance, food delivery apps use Google Maps API for restaurant locations. Applications include OpenAI API for NLP integration and chatbot connections with Salesforce CRM. 19. Graphics processing units, or GPUs, accelerate data processing, speeding up AI model training. For example, NVIDIA A100 GPUs are used for training large-scale AI models. Applications include Google Cloud GPU and Amazon EC2 GPU powering models like GPT-4. 20. Automation AI and ML automate repetitive tasks, freeing humans for strategic work. For instance, Amazon or Google chatbots provide 24/7 customer support. Applications include Tesla's automated production lines and Deloitte's RPA systems for document processing. You've just explored 20 essential AI concepts, the foundation for understanding the future of technology. As someone once said, concepts shape understanding, and understanding shapes reality. Which concept impressed you the most? Share your thoughts in the comments. Don't forget to like and subscribe to Chloe Tech AI for more exciting tech insights.